Implementing dynamic lighting in game environments can significantly enhance visual realism, atmosphere, and immersion. Here's a step-by-step guide to help you implement dynamic lighting in your game environments using popular game engines like Unity or Unreal Engine. 1. Choose the right game engine. Select a game engine that supports dynamic lighting and provides tools and features for creating and managing light sources, shadows, and effects. Unity and Unreal Engine are popular choices for implementing dynamic lighting in game environments. 2. Set up scene lighting. Begin by setting up the overall lighting in your game scene. Place directional lights, point lights, spotlights, or other light sources to illuminate the environment and objects within it. Experiment with different lighting configurations, intensities, colors, and angles to achieve the desired mood, atmosphere, and visual effects. 3. Enable real-time lighting. Enable real-time lighting in your game engine settings to allow dynamic changes to lighting conditions during gameplay. Real-time lighting enables effects such as dynamic shadows, reflections, and light occlusion. 4. Use dynamic light sources. Place dynamic light sources in your game environment to simulate moving or changing light conditions. Dynamic lights can include moving objects with emissive materials, such as torches, lanterns, or vehicle headlights. Experiment with animated light sources, flickering effects, and pulsating patterns to create dynamic and visually engaging lighting effects. 5. Implement shadows and reflections. Enable dynamic shadows and reflections in your game engine to enhance realism and depth perception. Use shadow casting lights to create realistic shadows that react to moving objects and changing light sources. Adjust shadow settings, such as shadow resolution, distance, and bias, to optimize performance and visual quality. Implement screen space reflections or reflection probes to simulate reflective surfaces and materials in the environment. 6. Optimize performance. Optimize your dynamic lighting setup to maintain a consistent frame rate and performance during gameplay. Consider factors such as the number of light sources, shadow quality, render distance, and hardware requirements. Use optimization techniques such as light baking, occlusion culling, and level of detail (LOD) to reduce rendering overhead and improve overall performance. 7. Add atmospheric effects. Enhance the atmosphere and mood of your game environments by adding atmospheric effects such as fog, haze, or volumetric lighting. These effects can add depth, drama, and realism to your scenes by simulating atmospheric scattering and light diffusion. Experiment with particle effects, volumetric shaders, and post-processing effects to create dynamic weather effects such as rain, snow, or fog that interact with lighting in the environment. 8. Test and iterate. Test your dynamic lighting setup in different gameplay scenarios and environments to ensure consistency, visual quality, and performance across different platforms and hardware configurations. Gather feedback from playtesting, peer review, and user experience testing to identify areas for improvement and iteration. Continuously refine and optimize your dynamic lighting implementation based on player feedback and performance metrics. By following these steps and leveraging the capabilities of your chosen game engine, you can implement dynamic lighting in your game environments to create immersive, visually stunning, and dynamic gaming experiences.